Hello. Yeah, what's up everyone? This is your video page 308 part C. We have done listing all of question one's statements. We have created a paragraph proof turned into a flowchart proof for Madison. We're now going to do Abelina's proof plan to create a two-column proof. If you haven't watched the first part of our videos together, that is the one from page 307 where we process that page, please do that. And then we have identified the statements and reasons. So we're going to need to know all of those details here for this video. I'm going to move my face out of the way. Let's talk about what Abelina has to do. Abelina has to identify that angle 4 and angle 5 are congruent. She's got a whole list of reasons and statements, and we're going to make sure that we identify them in a two-column proof structure. Of course, it always starts with the given. So that's going to be the first statement-reason relationship that we have. And it looks exactly like what Madison said since they're both using the same information. So maybe like a number 1 and a number 1 given goes first. For statements, I'm going to say what was before. Line W is parallel to line X, and Z is a transversal. Oh, I'm running out of room. I got to write smaller. Can I zoom in at all? Nah, you'll deal with that. I'll show you the whole thing in a minute. But just follow along as best you can right now. Then angle 2, not line angle 2, step 2. So we got to look through her proof, and we got to see what she said after that, right? So I can put a little 1 right there, something I didn't do in the previous video for the flowchart proof, but I'll do it now for the two column. This right here, all of this is step 1. Then we continue down the sentences. So I know that, looks like a step 2 is happening, angle 4 and angle 6 are supplementary. Angle 4 and angle 6 are supplementary. Now, that might be a word that's on the screen, yeah, right here. Supplementary angles, zoom in if you can, if it comes through. Supplementary angles add to 180, but we have to be able to define that they are supplementary. So I'm going to say that step 2, oh, she says right here, they are same side interior angles. So I'm going to take what I wrote in pink and I'm going to put in the reasons, or I highlighted in pink, I'm going to put in the reasons. Same side interior, whatever word I'm trying to write, interior angles. Okay, number 3, she says again, angle 5 and angle 6 are also supplementary because they form a linear pair. So statement 3, put a little 3 right here. Okay, statement 3, angle 5 and angle 6 are supplementary. It looks exactly like the previous statement because it really kind of is. We need that connection. There's an angle that's in common for both of them. And then because we find the angle that's in common for both of them, we're able to then swap that angle out using, do I have it quickly? I do. Substitution. We need to use substitution, and it's going to be using angle 6 to get that one kicked out. The fact that angle 5 and angle 6 are supplementary is because they are a linear pair. So we're going to use what she said, the linear pair postulate. All right, as a reminder, if you don't have the linear pair postulate card made, please do. Those two angles look like this and they make a straight line. It's one of our other vocab words. All right, number 4. Okay, so I'm looking down at the list here. If we have the fact that 4 and 6 are supplementary, then here we go, 4 and also 5. So we're going to write it out. The measure of angle 4 plus the measure of angle 6 equals 180 degrees. Literally, this is by the definition of supplementary, right? That's what it means. Supplementary means they add up to 180 degrees. So then write the sentence where they add up to 180 degrees. Statement 5. The measure of angle 5 plus the measure of angle 6 also equals 180. By the exact same reason, definition of supplementary angles, right? Because they add up to 180. So if they're going to equal the same thing, they're going to equal 180, the two angles that are in common, kick it out. Subtract it away from both sides. Statement 6. You know what? I just realized something. She uses congruent supplements theorem. So I can jump. The statement 6 that I'm reading off my notes versus what I want to write down actually uses congruent supplements. It's a little bit different than what I highlighted in the first video. I'm actually going to take out, we don't need any more definition of supplementary or substitution property. We can just say, boom, angle 4 and angle 5 are congruent. Angle 4 and angle 5 are congruent. I don't know why I wrote it out in sentence form. I should have written it out in symbols. I should have written it out like this. Angle 4 is congruent to angle 5. And the reason is congruent supplements theorem. Right, which I have ready to share with you somewhere. I've got so many note cards right now. Yes, boom, there it is. Congruent supplements theorem says that if these two angles are congruent, these angles are supplementary, these angles are supplementary, then angle 1 and angle 3, which we didn't talk about at the beginning because I talked about 2 and 4 first. Well, angle 1 and angle 3, they happen to also be congruent. So there's our congruent supplements card. At the end of a proof, we're allowed to put like 3 dots. Those 3 dots stand for the Greek words quod erat demonstrandum, which means that which was meant to be proved. Maybe it's Latin. I think it's Latin. Anyway, there it is. We are done with the proof. We're done on page 308. Thank you for watching this video. We're going to continue the conversation, make a note card for alternate interior angles, because when we know if 2 lines are parallel cut by a transversal, then the alternate interior angles, like angle 3 and angle 6, are congruent. And we don't have to go through an entire paragraph proof any longer to say why that is. We just, boom, throw out the reason, throw out the shortcut. I know by definition. Thank you for watching this video. Thank you for being here for page 308. Please click on the next part to watch page 309. See you on the math trail.